parallel. Combination of capacitors basically. So one thing we know is that if we have a capacitor having plus Q charge and minus Q charge and a capacitance C, I can write Q is equal to CV. Okay. This is according to the definition of capacitance. We can write Q is equal to CV if this particular capacitor has plus Q and minus Q charges on the plates of the capacitor. Okay, and the C is the capacitance of the capacitor. Okay.
Yes.
Now let us do combinations of capacitor. So we have two combinations. One is series and parallel, right?
Yes, sir.
So first let us discuss parallel. In parallel combination, I have, let us say, two capacitors whose ends are basically connected. Okay, a parallel combination is a combination when the ends of both the plates or both the capacitors have the same potential difference. Is this clear? This is basically parallel combination. But in words, how do I define parallel combination? When the points across the capacitor, when the points across the plates of these capacitors are having the same potential difference. So the capacitor 1 has potential difference VA minus VB, the capacitor 2 has the potential difference VA minus VB. Is this clear?
Yes, sir.
Now, so I can say that the potential difference is same, right? From this
Sir, but
information.
if they're arranged in this format, how are we telling potential differences are same?
Potential difference is basically
Yes, sir.
potential of this point minus potential of this point, right?
But we take it like before the left plate of capacitor and right plate of.
We take it
Before left plate of capacitor and right plate of.
before left plate and right plate. What do you mean before? What do you mean by before left
In
plate?
the previous thing, the B and C part.
So that story had charging. Charges were accumulating.
Yes, sir.
Here we are not discussing any of it. We are not saying that I am charging this fellow, that fellow. I'm just saying I'm walking on a road, I saw it and I saw the points across these have the same potential difference. I can say they are parallel.
Okay, sir.
I have no story in that. I saw two capacitors whose ends have the same potential difference. They're parallel.
Yes, sir.
That's why I wrote the first thing is potential difference is same. In a parallel combination, to identify it as a parallel combination, we can check it through if the potential difference is the same.
Yes, sir.
Now, what is it in these combinations? What are we trying to do? If I have a situation like this where two capacitors are arranged this way, and if I want to replace them by only one capacitor, okay, so how much capacitance of that capacitor should be there which can replace these two capacitors? So if I remove these two and place a capacitor, single capacitor, how much capacitance should it have such that it replaces this particular situation and the rest of the system feels no different. That's the point. Okay. So
Yes,
if
sir.
I remove of these two and place a third capacitor, how much should this capacitance be so that the rest of the system, whatever the system might be, feels no
It should
difference?
have the same potential.
Yeah, feels no difference, or we can say same potential difference, or anything related, anything literally. It should have the same effect. These two and this one fellow should have the same effect. Is this clear?
Yes, sir.
Now,
There is a potential differences, sir. I mean,
we can
okay.
say potential difference is same, but potential difference same is just one segment of many things that are possible. How many things are possible? You will come up while you're solving the exercise problems, right? Every problem you will have a particular situation. Saying that how much capacitance should I have so that the potential difference should be VA and VB is just one part of many particular cases which are possible. But what is my
Yes.
agenda? My agenda is how much should the capacitance be such that it does the same thing that these two capacitors are doing in this particular combination.
Yes, sir.
What do I mean by same thing? Anything. It can be charge flow, it can be potential difference, it can be charge accumulated, it can be whatever. Rest of the story, whatever you have, should have no different effect, should have the same effect if I replace these two and place this one for particular fellow. Here?
Yes, sir.
Now, so in this situation, what did I figure out? The first thing that I figured out is that the potential difference is the same. Also, the same potential difference is same for the equivalent also, right? Now, let 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 V is equal to VA minus VB. Okay, so let us say this is the positive terminal, so positive charges are accumulated here, negative charges are accumulated here. Similarly for this fellow, that means I am saying VA is basically the positive terminal and VB is the negative terminal, correct?
Yes, sir.
Therefore, here also I will have VA as my positive terminal and VB as my negative terminal. Okay.
Yes, sir.
So here also I'll have positive charges and here also I'll have negative charges. Clear?
Yes, sir.
So we are saying that the potential difference is the same. Let the charges accumulated over here be Q1 and Q2. Okay, so this is plus Q1, this is minus Q1, this is plus Q2, and this is minus Q2. Okay.
Yes, sir.
And let this be plus Q and minus Q. Now, why am I writing this Q1, Q2, Q? Because for the same potential difference, when I have different capacitance, according to the equation Q is equal to CV, for the same potential difference V, if I have different capacitance, I will have different charges. Q will be different, right? Therefore, I am giving them Q1, Q2, and Q. And now let me write those equations over here. So simply we have,
And then in the C2 you have, okay. Nothing, sir.
okay, I'm writing the equations over here. So I'll have Q1 is equal to C1V. Similarly, Q2 is equal to C2V. Okay, clear?
Yes, sir. Yes.
Similarly, I will have Q is equal to C equivalent into V. Is this clear?
Yes, sir.
Now, earlier you were saying that I said the replacement basically should ensure that everything else remains the same. So you said no potential difference. I said there are many cases which are possible. One other case I want to discuss. If this particular capacitor is taking plus Q charge through point A, the plus Q charge which is accumulated on the plate of this particular capacitor is basically coming through point A only, right? Can I say if the story has to be same in both the situations, that means from here also plus Q charge is the total amount of charge should be passing through Q.
Yes, sir.
And similarly on the opposite end, minus Q charge is the total amount of charge that should be passing through B.
Yes, sir.
That means when I say the story has to be same, that means that that also means that the total charges that I am taking from point A should be same in both the cases. That means here I am taking plus Q charge from point A, which is eventually getting distributed into Q1 and
Yes, sir.
is this clear?
Yes, sir.
Now let me draw this particular thing over here, which we will use it in our future also further. So basically I have something like this, right? This is my plus Q1 charge, this is my plus Q2 charge. And from here, how much did it pass? It passed plus Q charge, correct?
Yes, sir.
Plus Q charge passed through from here and distributed itself as Q1 and Q2, right? Plus Q charge has passed through from this end and eventually accumulated as Q1 and Q2. So can I say my Q is nothing but Q1 plus Q2?
Yes, sir.
This is also the first important thing that we have to know is potential differences. The second important thing that we have to know is Q is equal to Q1 plus Q2 for parallel combination. Okay.
Yes, sir.
Therefore, what is Q? Q is C equivalent into V. What is Q1? C1 into V. And what is Q2? C2 into V. Therefore, I can say that my C equivalent, therefore I can say that my C equivalent is equal to C1 plus C2. Clear?
Yes, sir.
But this part everybody does everywhere.
Sir, you are giving same potential everywhere. Oh, that is potential. Yes, sir.
I am saying that whatever we have derived, everyone, everywhere, every place will do this derivation. Not a big deal at all. This was just a simple story. But the other way of looking at these things, let us say, according to me, the more useful way and the most efficient way and all, is how do I look at it is, I have an equation Q is equal to CB, right? Yeah, I have an equation Q is equal to CB. In this, I am saying that potential difference is same. So can I say for my parallel combination, my V is behaving as a constant?
Yes, sir.
That means can I say that my charges are basically proportional to the capacitance?
Yes, sir.
That means can I say the ratio Q1 is to Q2 should be is nothing but C1 is to C2?
One is to C2.
By knowing this ratio, I can do a lot of things. If I know charge total, if I know the total charge Q, I can write it using these ratios also.
Yes.
Suppose 5 coulombs has gone and is distributed as 1:2. Okay, or let me say 2:3 to make it easier. Total of 5 coulomb charge is taken. The ratio of charges is seen to be 2:3. That means 2 coulombs went there, 3 coulombs went here. Are you getting my point?
Yes, sir.
By knowing this ratio, I can do, and according to me, there are this fellow will solve a lot of problems more efficiently. This is also important that this everybody does this. Not a big deal about that. Okay. Wait. Let us finish up series also. Okay.
Yes, sir.
Now, for a series combination, how should it look like? So basically, I have a capacitor and another capacitor attached next to each other. Okay, so let us say this point is A, B, and this is C. Right?
Yes, sir.
So let the capacitance over here is C1 and the capacitance over here is C2.
Yes, sir.
If I have plus Q charges accumulated over here, then I will have minus Q accumulated on the right side of that same capacitor. Now, if you look at the middle part, this is an isolated conductor.
Completely minus Q.
Here it is minus Q, that means here it should be plus Q.
Okay, like if we draw some questions.
I am drawing this middle part over here.
Okay.
And what are we seeing? What are we focusing on? It's an isolated conductor, correct?
Yes, sir.
So if my capacitor C1 has plus Q and minus Q charges accumulated on the plates, okay, that means for my middle portion on the left side I have minus Q charges. And this is an isolated conductor, this middle portion. It is not attached to anyone. So if you extract minus Q charges towards left, automatically plus Q charges are extracted towards right.
Yes, sir.
Because it's an isolated conductor. That means the charges over here are plus Q and therefore the charges over here are minus.
Sir, if we draw a Gaussian surface, like we know electric field is 0, and we can tell that some minus Q plus something equal to this.
Yeah, but if you draw Gaussian surface, you will realize that the electric field is not 0. Electric field between the plates of the capacitor is from positive to negative charges.
There's no electric field in between of.
In between of what?
In the between of C1, sir.
In between of C1 means in between the plates of the capacitor.
Yes, sir.
That's exactly what I was saying. That the left side of the plate has positive charge, the right side of the plate has negative charge. There will be sigma by 2 epsilon naught due to positive, sigma by 2 epsilon naught due to negative in the same direction. Therefore, the electric field between the plates of the capacitor is sigma by epsilon naught. Positive charges, negative charges, electric field from positive to negative. Yesterday, last class, day before yesterday, we did it. Anyways, so because of isolated conductor, I can say that positive charges plus Q is accumulated here, negative charges minus Q is accumulated over here, right? Keep thinking, no problem. Okay?
Yes, sir.
Now, what is my agenda over here? My agenda is basically, if I replace these two capacitors by one single capacitor, the entire story remains the same. That also means, again, you can say that the potential across should be A and C. That is also correct. Or I can say, what is the charges taken from A? It is plus Q. What is the charges taken from C? Is minus Q. Correct?
Yes, sir.
In series, can I say that the charges which are accumulated are same? Plus Q minus Q plus Q minus Q plus Q minus Q. Everywhere charges.
Isn't it 2 times of that?
Isn't it 2 times of what?
Positive
My
charges.
desire is to extract plus Q charges from A and minus Q charges from C. What is happening in an isolated conductor is happening.
Yes, sir.
But from A and C, how many charges are going? Plus Q and minus Q are going.
Yes, sir.
So if I want the same effect to be over here, from A plus Q and from C minus Q charges are flowing, correct?
Yes, sir.
Now if I write the equations for all the three, I will write Q is equal to C1 into V. But see this, V is nothing but V1. What is my V1? V1 is VA minus VB, correct?
Yes, sir.
Also, I can write Q is equal to, for this C2, into V2. What is my V2? V2 is?
Sir, why are we telling potentials here at
Why are we telling the potentials here are?
difference? Different.
Now, if you look at this equation, you have the same charge, but you have different capacitance. So V has to be different. I want to get Q for different C's. That means my V has to be different.
Yes, sir.
Right? Okay.
Yes, sir.
Now, here what I am saying is my potential difference across C1 and C2, if it is V1 and V2, first what is my V1, what is my V2? V1 is VA minus VB. V2 is VB minus VC. And if I say the potential difference across A and C is V, then I can say V is equal to VA minus VC.
Sir, we know at V it is like positive potential, then at V what is it? Sir, at A we know it is having positive potential, then what about B?
What about B?
Yes, sir.
What about B? Good point.
Sir,
I understood what you're saying. It's not always necessary for VB to be negative. It is necessary for VB to be less than VA. The important thing is A is higher potential, B is lower potential. Therefore, positive charges are going in that direction and negative charges are coming in this direction.
so from V, like positive and negative are getting splitted again.
From B, positive and negative are being splitted again.
Not again. They're getting splitted. Yes, sir.
Positive and negative are distributing them.
Okay.
Fine?
Yes, sir.
One thing, usually what happens when we discuss any kind of a physical quantity, because we are in this whatever rat race or whatever we say, so we are solving a lot of problems and make ourselves align in a particular way. But if you think of it, potential is basically ability. Ability is always relative, right? If Usain Bolt is the only person on the planet, who is he challenging? He has great ability. What ability? He is the only person on this planet. Let him run. We'll forget person. He is the only moving thing on this planet. Even trees, no wind also. Okay, winds also said, okay, we are not there. Trees are also like this. Okay, fine, we are not moving. Only Usain Bolt is there. Run, 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 run. Who is he challenging? Nothing. How can you say if his ability is higher, lower? All these are relative terms.
Yes, sir.
Therefore, I can say that potential is a relative term.
Yes, sir.
Field is not a relative term. Field is the effect that is present over there.
Yes, sir.
So I wore a proper thorough mask from top to bottom of my body. Night 3 o'clock went into a bank, opened all the lockers because Doom 10 and stole all the money and came out only to see cops are there. I am saying that when I look at the cops, I will have some effect, right? I am all
Yes.
happy and glory. Yes, I am going to, don't know what, Robin Hood or whatever. But I come out of that bank and when I see the cops, there is an effect on me. Has nothing to do with the ability that I have. Of course, when I say nothing to do, doesn't mean that they are not related. E is equal to minus dV by dr. They are related. But ability has a different sense completely and effect has a different sense completely. Is this?
Yes, sir.
I will say, Arey, what gravity, gravity? Earth has no gravity only. Go to Jupiter, then you will know. And Jupiter
Okay.
will say, why play all around with me? Go to Sun, then you will know. Sun will say, go to another star. Everybody else will say, forget all this, go talk to black hole. So everything is relative, right?
Yes, sir.
Ability is a relative term, whereas effect is not a relative term. Effect is an actual term that happens. Why I am saying this is because you might see there are negative charges accumulated, and here also negative charges accumulated. So what is this B doing? Is it negative potential, positive potential? When we talk of potential, it is not necessary for them to be negative to give negative charges or positive to give positive charges. Only potential difference is what is important. When we have VA is greater than VB, positive charges will move from A to B and negative charges will move from B to A. And these two plates are actually not connected. Therefore, negative charges when they are moving from B to A will get accumulated right side. Positive charges will get accumulated on the left side. Is this clear? So that's
Yes.
how story is working. We really don't have to. But I explained it to you as V plus and V minus so that it becomes more convincing for us to understand initially. But it's not necessary. It's more importantly higher potential and lower potential. Okay.
So C is having A lesser than B.
C is having lesser than B. That's why positive charges are going from B to C and negative charges are going from C to B.
Yes, sir.
Right. Now coming back to our combination. In this combination, we are saying that the charges are same, right?
Yes, sir.
Now applying that particular equation to each capacitor, C1 V1, C2 V2. Why I
Yes.
need V1 and V2? Because potential differences are different. A minus B and this is B minus C. And now the last fellow is basically Q is equal to C equivalent into VA minus VC.
Yes, sir.
Correct? Or we can
Yes.
write it as V also. Equal to C equivalent into V. Here, what is the equation that I can identify using these three basically? What I can identify is I can get V as V1 plus V2.
Yes,
When
sir.
I add these two, minus VB plus VB will cancel. So V is equal to V1 plus. Now substitute. What is V? Q by C equivalent. Correct?
Yes, sir.
V1 is Q by C1 and V2 is Q by C2. Therefore, for a series combination, I can say Q will get cancelled everywhere. 1 by C equivalent is equal to 1 by C1 plus 1 by C2. Correct?
Yes, sir.
So, two important points to note. One is for a series combination, 1 by C equivalent is 1 by C1 plus 1 by C2, and charges are basically the same on all the capacitors. Correct? Again, as I said, everybody will do this, but there is something else that we need to look at, which we will use in our problems to solve more efficiently. Okay? We are saying charges are same over here. So that means Q is a constant, right?
Yes, sir.
But my Q is nothing but CV. So I can say CV is a constant.
Yes, sir.
That means I can say that my potential difference is inversely proportional to my capacitance in series combination.
Yes, sir.
That means I can say that my V1 is to V2 potential ratio is nothing but C2 is to C1.
Yes, sir.
I gave 5 volts across A and C. I gave 5 volts across A and C potential total. Capacitance I gave ratio 2 is to 3. This is 2, that is 3. But according to my ratio, potential ratio will reverse. That means potential ratio 3 is to 2.
Yes, sir.
So if I am giving 5 volts, this fellow will have 3 volts, that fellow will have 2 volts. I don't have to do huge mathematics anywhere to find
Yes,
that
sir.
out. Or else I can do with big solving also. But using this, I can get it faster. Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.